Hi there, this is Algebra 2 Saxon Math, Lesson 127. So on this lesson, we're just going to be talking about some definitions. We're not going to necessarily go through all of them, just so you're familiar with it. So the first thing is we need to just remind you that in geometry, there's some terms that are not able to be defined exactly, and they call those undefined terms or primitive terms. Just know that they exist. For instance, a point, a curve, a line, a plane are considered these primitive terms. The complete meaning of primitive terms is found in totality of the axioms that use them. So you just need to know that there are terms that can't be defined exactly. Now, so if we think of a flat, say a tabletop, a rectangular tabletop, rectangular surfaces, we think of a plane as a flat surface. It has no thickness and extends without bound forever. That's what a plane is, and that's why it can't be exactly defined, because it goes on without bounds and it doesn't have thickness. But in our eyes, we do see thickness because we can draw it, but technically it doesn't. So figures that can be drawn on this flat surface are called planar. Okay, so if I want to draw a line on it, it's going to be a planar. And this is the study of these figures is called just plane geometry. The study of three-dimensional geometric figures is called solid geometry. Okay, for instance, this would be a solid, right? It's not a flat surface, it's a three-dimensional square. Now, here are some definitions. I'm just going to go through them. What is collinear? So collinear is one that they give us. So basically, collinear says if you have 2 points, okay, they determine a line. So I can call this point A and point B. Now, and if a third point lies on that line, we say that they are collinear. Okay, so point A, B, and C are shown here, and they're all on the same line, thus they are collinear. All right, so a line can be parallel to a plane. So if we have a plane and we have a line above it, okay, well, parallel means they never cross. So they have no common point. So they can be parallel. Likewise, you could have two, and I can't draw. If you look at the bottom of page 520, they draw it, and they draw it much better, three-dimensional. You can see that there's two planes. Think of two sheets of paper that are horizontally held, and they don't ever cross. Okay, and we can say that those planes are parallel. Now, if you look to the right of that figure drawn in your book, you've got two planes that actually intersect at a point. And if you see, they intersect, at a line, they intersect at line ABC or AC or AB, whatever you want to call that line, because remember, you can name a line with just need 2 points, any 2 points in any order. So they cross at that point. And you see that the angles, if you look at that figure, angle MAD or DAM, and on the other side it forms angles. We call those angles dihedral angles, okay, when the angles made by the two intersecting planes, okay. And you note that the line we said ABC goes through, they intersect there. So that line is both on plane M and plane N. Okay, that's important. So the next postulate so now we're going to use these terms, and they're going to give you postulates, and these are used for like defining things or proofs or in geometry. So, for instance, they gave us a plane, and they have 3 points, A, B, and C. Okay, so we say that 3 collinear points do not determine a plane. So earlier we drew a line with 3 points on it. That doesn't necessarily mean defines a plane. But we have a postulate that says we have 3 points that are not collinear. So these 3 points, remember, collinear means they're on the same line, are not collinear. do determine a plane. So that's just a postulate you gotta know. If you have 3 points, they determine a plane that are non-collinear. Since 2 of these points determine a line, so if we look at the page 521 on the right side, you have 2 points that are on the same line, and then you have a line and you have a point C. So also we can say that a plane can be determined by a line and a point. Okay, the next thing they say, if you have intersecting lines, okay, the same 3 points, and they determine 2 intersecting lines, it also determines a plane. It means they're on the same plane. 2 parallel lines also determine a plane. So the definition of parallel line requires that the lines be in the same plane. So if lines A, B, and C, D, if you look at the next picture on that page, the lines must be in the same plane because they're parallel. Okay? And then they also tell you, well, since point P and point C and D determine a plane, there's only one plane that contains point P, C, D. Thus, all 5 points lie in the same plane. All right. So these are just postulates that are coming up that they are just telling you that exist. So we can also postulate that if a line intersects a plane that does not contain the line, meaning you have a line that goes through and they intersect at a point. They're telling you the line intersects a plane at only one point. So you see they have plane M and they have line ST going through this plane at the point P. Okay. Now, parallel lines are defined to be in the same plane and do not intersect. Now, skew lines. This one's always difficult. It's very abstract because it looks like, well, if the lines go on forever and planes go on or lines go on forever, then at some point they're going to cross. But skew lines are lines in space that are neither parallel nor do they ever intersect. They made an attempt to draw, and so basically you're saying, if you look at it the way it's drawn, you can't tell, but they tell you in the next little blurb after the drawing that line F and E are not parallel and they don't intersect, so they're skew lines. And then they tell you another way to define skew lines is say they are not in the same plane, meaning F must be, for it not to be in that plane, then it must be parallel to that. Okay? Now, if a line is perpendicular to each of 2 intersecting lines at their point of intersection, the line is parallel to all the lines in the plane that pass through that point. So if you go to the next page, they give you a plane, and then they give you, let's see, they call this line S, and they say this is line R, and this is point T. Okay, so these 2 lines, okay, so they're perpendicular, okay, but this line S is not necessarily perpendicular to this plane. They call this plane M, okay, but it's perpendicular to line R at point T. So any other line that goes through point T will be perpendicular to S, and that's what they're telling you. If you look at the right, they show you that example. They actually, I'm going to just continue with this, and they give you line C. They call this point F instead of T, and they call this one C, and they show you that that line A, which is S, is perpendicular to those 2 lines. Okay. And then they just want you, they go and make some of these proofs using these postulates and these definitions. And that's what example 127.1 and 127.2. So you don't necessarily need to know these, just kind of read through them and like again, they give you a given and then they say, okay, now prove this statement. And then you have to use these postulates, and it has to do a lot of times with triangles. So that's what those 2 are. So we won't go through this. You can go ahead and stop this and then just kind of summarize the definitions and the postulates just so you're familiar with them.